Welcome back, Java programmers. This is the 11th of my Java video tutorial series, and in this video we will talk about Java methods. Ever since we started programming at CPP, we've been using a method, and that method is the main method. Okay, like what I discussed in the Java video tutorial number 2, the main method is very important because if the main method is missing, if you don't include the main method in your class and you try to run it, an error message appears, meaning to say compiler cannot find the main method, and the main method is the execution point. Okay, that's the method compiler calls when you try to run your program. Okay, so if you only have one method in your class and you want to run it, that one method must be the main method. Okay, now let's define what Java method is. Java method, or simply method, is a part of a class, meaning to say a method must be inside a class. A method is housed by a Java class. Okay, it cannot be outside a class. It's impossible. It won't work. And a method is doing something. It could be calculation, it could be printing, anything. Okay, be assignment operation, whatever it is. But remember, before a method does its job, it must be invoked. It must be called. Now, a method is called by whom? Well, a method is called by another method. Okay, a method can invoke another method. A method from another class, or from the same class, or from another class in the same package, or whatever. Okay, so the thing is, before a method does its job, it must be invoked first. It must be called first. Okay, and then you might ask, what's the point of having another method beside the main? It's additional job, it's additional work. Well, you must think of some advantages. There are a few advantages of using methods. Well, first is to organize your code. Okay, well, it's very hard to manage if you have just one big class that has, let's say, 100,000, hundreds of thousands of lines of code. You think you can manage that? Yeah, of course you can, but it would be harder if you have 100,000 or 200,000, or hundreds of thousands of lines in just one class. What if you separate, you categorize, you cut into pieces. You cut your one big class into chunks, into several methods. It would be easier for you to manage. You don't have to go through the whole class one by one, line by line. Okay, if you just want to go to this particular part of your class, so just go to that method. Okay, you don't go through the whole class. So that would be easier for you to manage your class if they are in several methods. Okay, and if I were the Bill Gates, yeah, I would be assigning several programmers. Okay, I would give them their respective methods. Okay, I can give them all the methods that I want them to create, and then After a few months, for example, I collect all their methods, and I will put all of them in one class. So as an employer, it would be easier for me to distribute the work to my employees, right? So that's another advantage of using methods. And another thing is that you might agree with me later is, you can reuse codes. Okay, how can we do that? How can we reuse codes? Well, a bit later, I will give you an example. Okay, so, and for you to understand what methods are, Java methods are, let's have an example now, not later, now. Okay, so let's say, for example, this very simple program simply calculates two integers. Okay, so what I'm going to do is I'm going to declare two variables, and I'm going to initialize them to, of course, to any numbers, to any values. So at this point, in this case, I initialized n1 to 10, and I initialized n2 to 20. Okay, now since I want this program, this class, to calculate the sum and displays, I would write this statement. Let me just say sum, and then of course displays the sum, calculates the sum and displays it. So n1 plus n2. Okay, so let's see. Okay, it's 30, it's correct. But what if I want to add another set of values? Okay, so I'm going to do this again, right? I'm going to do this again. Okay, so I'm gonna have separate set of values. Let's say 20 and 30. Okay, so let's see. It's still correct, right? What if I want to add another set of values for the third time, for the fifth time, for the sixth, for the seventh, etc., etc.? Well, you might tell me that, hey, Mr. AP, just put it in a loop. Yes, I would agree to that. In this class, yeah, we can do that. What if another method who wants to call this, okay, because that method wants to calculate also a set of numbers, right? And that method doesn't need to repeat, doesn't need a loop. So in other words, this cannot be cannot be called by other methods from another class. So, well, I don't think this code is efficient enough. Again, as much as possible, we try to create an efficient code. Okay, well, again, putting this in a loop would be okay, but what if another method from another class wants to call this method but doesn't need a loop? So that's where the problem comes in. Okay, so what I'm gonna do is I'm gonna create a method instead. Okay, another public static method. In this case, let me call it getSum. Oh, by the way, when you are creating a method, you have to name it, right? So in this case, I am naming it getSum. And in Java, we have to follow convention in naming methods. Well, the first letter of the word of the method name is in small letter by convention. Okay, it means that when we say by convention, you may not follow it, but since you're using Java, so you might follow the rules, right? So by convention, method name starts with a small letter, and if it consists of more than one, if it consists of two or more words, well, the succeeding words succeeding words start with capital letter. Okay, now again, this is my method declaration. It starts with access modifier public, meaning to say any methods from the same class or from another class can call this. But you may not, again, you may not type public explicitly. So by doing so, you are using access modifier package, meaning to say getSum method can only be called by another classes, by methods from another classes, but in the same package, assign package. So I'm using assign package here. So again, if you don't explicitly declare your method public, by default, the access modifier is package. Any methods from another class in the same package where this class is can call this method. But most of the time, okay, a method is, but you can declare that. It's up to you, whatever your preference is, whatever your needs are, okay? But in my videos, I am declaring my methods public. And then static means getSum can be invoked, can be accessed, can be called by any other methods without creating an object of the class where it is. In this case, it's Java methods class. Okay, so again, getSum is a method that can be called by any methods without using any objects. Okay, it can be called directly. Then void. Void is what we call return data type. Return data type void, meaning this method is doing something but doesn't return any values to the caller. Okay, later on I will expound on that, but in the meantime, when you see a void, if a method is void, meaning to say the method does not return any values. Okay, but don't worry, later, a bit later, I will explain this further. And then followed by the name of the class, like what I just explained a few minutes ago. You have to follow convention. Now, the method is declared, okay? Of course, the body of the method is enclosed in opening and closing curly braces, okay? Just like what main has. The body of the main is enclosed in opening and closing curly braces. Okay, now let's write the body of the method this time. So I named my method getSum because it does calculate the sum. So remember, when you name your method, it's like you give it a name that sounds like a verb. Okay, getSum, calculate sum, or not just X, not just Y. Make sure that the name of the method is relevant to what it does. Okay, so getSum is fine. Okay, now again, getSum calculates and of course displays. So I'm gonna get one of the print line statements in the main and I put it in the method. So in other words, the getSum is calculating, getSum calculates and displays the whole thing. But the problem here is N1 and N2 are underlined, meaning to say they are not found. Okay, so they must be declared in getSum. While you might say, Mr. AP, they are already declared here. But the problem is they are declared, yes, in the main, not in this method. Because these methods are different from each other, so they must have their own local variables. They must have their own variables. Okay, so If n1 and n2 are declared in the main, it doesn't mean that they are also declared in getSum. Okay, remember these are local variables, so it can be accessed in the method where they are declared. So n1 and n2 are just declared in the main, so they cannot be accessed by any other methods. So how to fix this problem? So again, getSum has to have its own n1 and n2. GetSum method has to have its own local variables, which are n1 and n2. Okay, but now to know that to know how to declare n1 and n2 in GetSum, let me ask you something. Now, what does GetSum need to do its job? Again, its job is to calculate the sum of two integers. So, in other words, it needs the two values. Okay? So, where would these two values come from? Where would these two values would be coming from? Of course, whoever calls GetSum, that is the one that is responsible in giving the two values to the GetSum. So GetSum can do its job. Okay? So I don't have, oh by the way, I have to delete this already because it's already done in the method. Okay? Now let's go back to the calling. Like what I said, GetSum calculates the sum of two numbers. And who calls the main? Who calls the GetSum? Of course, the main method. So how to call a method? So just write the name of the method, of course, followed by a pair of parentheses because GetSum is a method. Again, GetSum needs the two values. So it is the responsibility of the caller, which is in this case, the main, to pass the two values here. So GetSum is called by the main, and main passes n1 and n2. So this is what we call method calling. Method calling is in the caller, which is the main, and the callee is this. This is the callee. Okay. Now, if the caller is calling GetSum and passes, and if main calls GetSum and passes n1 and n2, well, what is GetSum supposed to do? GetSum supposed to accept the two values passed by the main. So how does a method accept? So there must be two parameters, two variables. Okay, so these two variables, declared variables here, are called parameters. And these two that are being passed are arguments. Okay, so arguments are in the calling method, and the parameters are in the callee. Okay, one more time. The arguments are in the caller. Okay, inside the parentheses of the method that is being called by the caller, and the parameters are in the callee. So main is the caller. It is calling GetSum. It calls GetSum and passes n1 and n2, and the callee accepts the two. Well, if you notice, they have the same name. n1 here and n1 in the GetSum, n2 in the main, and n2 in the GetSum. Well, it's just so happened. Well, I can change n1 in the callee as num1, and I can change integer n2 in the callee as 2 num2. Okay, so they are just names. They may be different because these are two different methods, so they can have their own sets of variables. Right? Now, what matters is, if there are two arguments, there must also be two parameters. If the first argument is of type integer, well, the first parameter must be of type integer as well. If the second argument is of type integer, the second parameter must be of type integer. Those things matter, not the names, okay? Naming doesn't matter, okay? What matters, again, the number of arguments must be the same as the number of the parameters. The data type of the arguments, the data types of the arguments must be the same as the data types of the parameters, okay? Not the naming. Now, here, let's try to run the code if it's working correctly, okay? Oops, yep, it works. Now, let's go back to the return data type void. I said a while ago that if a method is void, it does not return any values to the caller because it's void. Now, since it's return, it prints, well, it's okay to declare your method getSumVoid. What if the printing is happening in the main? So what is the main method supposed to print? The result of this, right? The result of num1 plus num2. That is the value that getSum returns to the caller. This is the value that getSum is supposed to return to the caller, so the caller can print it. Okay, so let's change the scenario this time. Instead of the getSum is printing, why not the main print it? Okay, let's the main. Let's put the printing in the main, okay, instead of in the getSum. Okay, so in other words, void must be deleted and must be replaced by int. Why int? So I changed the return data type from void to int because I want getSum to return this value to the caller, because the caller, which is the main, prints it. Okay, so what is the result? What is the data type of the result of this addition here? If you add int to int, then the result is of type int. That's why the data type, the return data type, is int, because the return value is of type int. Okay, so I'm gonna write a keyword return. Okay, so the getSum method returns to the caller. Now, there's another way of doing this. You can create another variable, okay, of type int, and you can do this. Sum equals num1 plus num2, and instead of returning this, you can return sum. You can do that, right? Or simply you can put this here, straight to the point, straightforward. Okay, or simply, this is better. This is what we call the best. Okay, it's more efficient than creating another variable. Okay, instead of using another memory location, just return the value of this operation directly, straight to the point. Very straightforward. Now, if getSum returns a value to the caller, so in other words, this has a value. If num1, okay, n1 is passed to the callee, which has a value of 10. So in other words, num1 is equal to 10, and n2 is passed to the callee, okay, which is represented by num2 in the callee. And if n2 has a value of 20, so also num2 has a value of 20. So if you add num1 to num2, what is the value? 10 plus 20 is 30. So in other words, 30 is returned. So in other words, this has a value of 30. And that value is what the main is printing. Okay? That's the value the main is printing. So we tried the method void, meaning it doesn't return any values, it simply prints. Okay, the printing is in the method itself. But what if the caller needs the value so it could print it? So this time getSum cannot be void because the caller wants to print the value, the result of this. Alright, so getSum must return it to the caller. And since it has return statement, this shouldn't be void. It should be int because the result of this is of type int. Num1 is of type int and num2 is of type int. So int plus int, of course, it's int. So it should be, return data type should be int. Okay, now let's run it. Let's see if it still works, and actually it does. Yes, indeed. Okay, now remember, this is what we call passing, right? The main, the caller, calls the method and passes the two values. But actually, what is being passed, what are being passed here are just copies of n1 and n2, copies of 10 and 20. So in other words, n1 is equal to 10, so a copy of 10 is passed to n1, and n2 is equal to 20, and a copy of 20 is passed to getSum. So to prove to you that it's just a copy, let me try to change the value of n1 to any number, let's say 100. And let me change the value of num2 to 200, for example. So even though I changed the value of num1 from 10 to 100, even though I changed the value of num2 from 20 to 200, still n1 here is equal to 10 and n2 here is still equal to 20. Okay, now to prove to you, let me display the original value of n1 here. Okay, and after the calling, let me display the value of n1 and n2 again in the main. Okay, let's see. So when I run this code, I shall see 10, 20, and then 300, and then 10, 20. So in the calling, we passed the copies of 10 and 20, but 10 and 20 are changed. Okay, num1 now is not 10 anymore, it's 100 because of this assignment operation, and 20 is not 20 anymore, it's now 200 because of this assignment operation. So even though we changed 10 and 20 to 100 and 200 respectively, still the original are the same. They were not changed. And to prove to you, let's run the code. There you go. See, the first line of the output is 1020 because this is executed first. So n1 has a value of 10 and 10 is displayed, and then n2 has the value of 20, so 20 is displayed here. and then followed by the calling of n1 and n2, get sum, sorry, and passing of n1, copy of n1, and a copy of n2. So this one has a value of 10 and this one has a value of 20. But in the body of get sum, I changed 10 to 100 and I changed 20 to 200, and that's the sum get sum returns to the caller, and that's the one being printed by the caller, which is the main. So you see 300, not 30, because the values have been changed to 100 and 200 respectively. But the execution returns to the caller to continue the execution, which is the printing of n1 and n2, which is the original values, not the changed values, not the revised values. Okay, so again, if a caller is passing, only a copies are passed. If the values are of type primitive, that's the point. If n1 is of type primitive, a copy is passed. Okay, but if the data type of a variable is non-primitive, it's a different story. I will explain that when we get to object-oriented programming. But in the meantime, we are just using primitive data types. Okay, one more time. If primitive data types are passed to the callee, then only copies are passed. Okay, only copies are passed. Okay, so again, let's recap. So in the calling, the caller passes, and these are what you call arguments. So let me delete this so it won't be so crowded. Okay, now these are called, again, one more time, these are called arguments. Then the arguments is found in the method calling inside the caller. So the caller is the main, and it calls getSum and passes a copy of n1 and n2. So these are called arguments. Then the callee accepts. These are called parameters. Okay, now namings doesn't matter. Naming of variables doesn't matter. If n1 in the main, you can change it in the callee. If n2 in the main, you can change it in the callee. If n1 and n2 are the arguments, you can have anything in the parameters. Okay, now what matters is the number of arguments must be the same as the number of parameters, and the data types of the arguments must match with the data types of the parameters. They must be of the same order. Okay, now let's have again, let's do this in a different way. Let me just delete this. I don't want to change the values. So let's recap. So I can redo this just by having another variable sum, another local variable sum. Okay, so let's say num1 plus num2. Okay, so this method returns the sum, because that's where the summation of num1 and num2 is. Now again, sum is a local variable, meaning to say this can only be accessed, this can only be used in this method alone. Main cannot use it. So if I use sum here, let's say for example I print the sum. Okay, sorry, it's underlined because sum is not declared in this method. Sum is not declared in the main where sum is being used. Sum is only declared in this method. So in other words, sum is a local variable, just like num1. So if I display num1 here, okay, it's underlined because it's not found, it's not in the main, it is only in this method. So that's what we call local variable. Now the next question you might ask me is that, is there any way to do this simple code here? Okay, let's have it. Okay, now if I already introduced to you the concept of local variable. Okay, if there is a local variable, also there's what we call global variables. Now global variables are accessible, can be accessed by all the methods in the same class. But here's the thing, a global variable technically not allowed simply because it is accessible to all parts of the code, just like what I said a few seconds ago. It is very hard to protect data from being changed if it can be accessed by any methods in the class. Okay, so as much as possible, do not declare global variables. Okay, now when we get to object-oriented programming, we will not be doing like what we are going to do now. Okay, I'm just trying to show you the other way of doing this. Again, the other way of doing this is by using a global variables. Now these global variables, technically they are not allowed. Okay, global variables technically not allowed simply because it is accessible to all parts of the code, and it's very easy. It's very hard to protect your data from being changed so easily. Okay, but even though, let me show you how to do it. Now if you have global variables, they must be outside the methods. Okay, they are still inside the class, but they are outside the methods. That's why they can be accessed by all the methods in the same class. So what does getSum need? The two values. So I'm going to declare a variable. Let's say, oh, let me just put this out. Okay, much easier. I don't have to declare. Just transfer this. Okay. Okay, sorry, my bad. Okay, let's transfer them outside so they become global. Now, if they are available to all the methods, getSum won't be needing this anymore because they are available globally, right? Again, global variables are accessible to all the methods. Remember the reason why we wrote this? It's because getSum needs them, right? But since these are all available globally, so you don't have to declare them as parameters. So getSum doesn't need parameters anymore. getSum doesn't need to accept from the caller anymore. So if the getSum doesn't need anything from the caller doesn't need to pass at all to the callee, right? One more time, the caller doesn't need to accept from the caller because whatever getSum needs, they are available globally. So if getSum doesn't need from the caller, the caller doesn't need to pass. So no arguments, no parameters. Okay, simply because of the global. So again, how to calculate the sum? So getSum can return it to the caller. Okay, so the getSum needs the n1 and the n2. But the problem is n1 and n2 are underlined even though they are declared globally. The thing is, who needs n1 and n2? getSum, right? And getSum is a static method. So in other words, if a method needs a variable, that variable must also be a static variable. Okay, so it must be static as well. So that's the rule. Do not forget that. If a method needs a variable to access, then that variable must also be a static. Okay? So the underlines are gone. So again, one more time, do not forget, this is not doing this. Declaring global variables is technically not allowed in Java simply because it is accessible to all parts of the code, and it is very hard to protect data from being changed. You know, any method can change the data. What if this data are money? You know, what if these values are money? What if this system, this program is a banking system? So it's very easy to manipulate the data. Okay, so make sure that you don't do this, you know, declaring of global variables. Now, when we get to object-oriented programming, I will teach you how to do this the other way. Okay, but I just did this just to show you the difference between a local variable, which is here in the get sum is the sum, and the global variable, meaning to say all the methods, we have two methods here, they can access n1. So for you to show that, you know, main can access get sum. Okay, so let me display n1 and n2. So see, no underlines. The main method, even though n1 and n2 are not declared in the main, still the main can access n1 and n2 because they are declared globally. Okay, so let's try to run it. 10, 20, and 30, which is correct. Okay, so that's the concept of global and local variables. Well, I hope you learned from this video. I hope this would help you in so many ways. Okay, I hope I explained, I gave justice to this. See you next time. Bye bye.